topic is germination of frequency and condition of oscillation in Colpitts Oscillator. As our dedicated team members Satyamkumar, Agrin Sakya, Pransu, Srishti Sagar, Pradasadi. Our content is introduction to oscillator, type of oscillator, what is Colpitts Oscillator, working principle, frequency determination, application, what is the disadvantage and conclusion. Oscillator. What is oscillator? Oscillator is an electronic circuit that generates periodic form without any external input signal. Oscillator convert DC signal from a power supply to AC signal. They are widely used in many devices, used in various applications such as signal generation, radio frequency transmission, clock generation. Here is the uh, systematic diagram to show the work of oscillator. Type of oscillator. There are various types of oscillators, including LC oscillators, RC oscillators, crystal oscillators, relaxation oscillators, feedback oscillators. Here we will discuss Colpitts oscillator and what is Colpitts oscillator? Colpitts oscillator is a type of LC oscillator used for generating sinusoidal waves at radio frequencies. It was invented by the American engineer Edwin H. Colpitts. Its principle relies on positive feedback through a taped capacitor divider network. Here are some more details for Colpitts oscillator, in which we can see that it consists of a tank circuit, which is an LC resonance circuit made of two series capacitors connected in parallel to inductor, and frequency of oscillation can be determined by using the values of the capacitors and inductor of the tank circuit. It is almost similar to the Hartley circuit, but it is termed as the electrical dual of the Hartley circuit, and it designed for the generation of high frequency sinusoidal oscillations with the radio frequencies typically ranging from 10 kilohertz to the 300 megahertz. Major difference between these two oscillators that uses taped capacitance, whereas the Hartley oscillator uses taped inductance. Here is the circuit diagram for the Colpitts oscillator, where we can see that in the tank circuit, the C1 and C2 is taped against the inductor. Here is the explanation for circuit, and in which we can see that it can be realized by using gain devices such as BJT or FET. And operational amplifier as similar in the other oscillator also. C1 and C2 have formed potential divider, and this tape capacitor in the circuit can be used as a source for feedback, and this setup can be used to provide better frequency stability compared to the Hartley oscillator, in which taped inductance is used for feedback setup. RE resistor in the above circuit provides stabilization for circuit against variation in temperature. A capacitor C connected in the circuit, which is parallel to the RE, provides low reactive path to the amplified AC signal, acting as bypass capacitor. Resistor R1 and R2 form voltage divider for circuit and provide bias to the transistor. Circuit consists of a RC coupled amplifier with common emitter configuration transistor. The coupling capacitor could block DC by providing an AC path from the collector to the tank circuit. Here is a working principle in which we can see that there is a charging and discharging of the capacitor and inductance, which forms the electrostatic energy transfer in the form of magnetic flux, and it forms the undamped oscillations of undamped harmonic oscillation in the tank circuit, and which forms the oscillations, and the continuous undamped oscillations can be obtained from the Barkhausen criteria. Here is the working principle in which we can see that for sustained oscillation, the total phase shift must be 360 degree or 0 degree. In the above circuit, as two capacitors C1 and C2 are center taped and grounded, the voltage across the capacitor C2 is 180 degree with the voltage across capacitor C1. The common emitter transistor produces 180 degree shift between the input and output voltage. Thus, from the Barkhausen criterion, we can get the undamped continuous oscillation. Here is a frequency determination expression where we can see that the resonant frequency is given by the 1 by 2 pi under root L in L1 into C, where L1 is the self inductance of the coil and C is the equivalent capacitance of the circuit of the capacitance connected in series. Here are the various applications for the Colpitts oscillator, where we can see that it is used for the generation of sinusoidal output signal with the very high frequencies. It can also be used for various commercial purposes such as RF signal generation in transmitters, local oscillator and radio receivers, test equipment, functional generators, frequency synthesizers. Here are some advantages and disadvantages, where we can see that in advantage, it is simple circuit design. It has high frequency stability, suitable for RF applications. Uh, in disadvantage, we can see that it is sensitive to the component tolerance, requires careful tuning, limited frequency range. We explained about the Colpitts oscillator theory, working applications, and along with its tank circuit. The Colpitts oscillator is very useful for electrical and electronic students. We hope that this explanation will clear your doubts, and it is the best presentation on Colpitts oscillator. Thank you.